Hello and welcome back to Saxon Math. This is lesson 113, adding and subtracting mixed numbers measures and multiplying by powers of 10. Measurements that include more than one unit of measurement are mixed measures. If we say that a movie is an hour and 40 minutes long, we have used a mixed measure that includes hours and minutes. When adding or subtracting mixed measures, we may need to convert from one unit to another. In lesson 102, we added and subtracted mixed measures involving pounds and ounces. In this lesson, we will consider other mixed measures. So for example, the hike from the trailhead to the waterfall took 1 hour 50 minutes. The return trip took 1 hour 40 minutes. Altogether, how many hours and minutes long was the hike? So if we were to add 50 minutes and 40 minutes to get 90 minutes, which equals 1 hour and 30 minutes. We change the 90 minutes to 1 hour and 30 minutes, and we write 30 minutes in the minutes column and add the 1 hour to the hours column. Then we add the hours. So 1 hour and 50 minutes plus 1 hour and 40 minutes equals 3 hours and 90 minutes, which is the same as 3 hours and 30 minutes. So if you have 1 hour and 50 minutes and you add the 1 hour and 40 minutes, it looks like this. You'd end up with 2 hours and 90 minutes. 2 hours and 90 minutes total. And that 90 minutes is equivalent. So this 90 is the same as 1 hour and 30 minutes. And if you take that 1 hour and 30 minutes and you add it to the 2 hours previous to that, you'd end up with 3 hours and 30 minutes. So that's how long it took the hike round trip. Example 2, to measure this vertical leap, Tyrone first reaches as high as he can against a wall. He reaches 6 feet 9 inches. Then he put chalk on his fingertips, and jumping as high as he can, he slaps the wall. The top of the chalk mark is 8 feet 7 inches. How high off the ground did Tyrone leap? So you need to take 8 feet 7 inches, and if we're going to subtract 6 feet 9 inches, you notice you run into a problem here. 7 minus 9 does not work, so we're going to borrow 7 feet. We're going to borrow 1 foot here. We're going to add 1 foot over here, which makes that 12. So remember, 12 inches equals 1 foot. So if you have 12 inches equaling 1 foot, you know that 12 plus 7 makes 19 inches. So it's basically like renaming this 8 feet 7 inches into 7 feet 19 inches. And now you can subtract 19 minus 9, which equals 10 inches. And you have to subtract the feet from the feet, and you have 1 foot there. So you'd have 1 foot 10 inches is his vertical leap. Example 3 will come up here in a second, but we can multiply by powers of 10 very easily. Multiplying by powers of 10 does not change the digits, only the place value of the digits. We can change the place value by moving the decimal point the number of places shown by the exponent. To write 1 2/10 times 10 to the third in standard notation, we simply move the decimal point 3 places to the right and fill the empty places with zeros. So 1 2/10, moving the decimal place to the right 3 places, would end up with 1200. So example, write 6 2/10 times 10 to the second power in standard notation. That's simply taking 6 2/10 times 100, because it has 2 zeros after it, and you would move the decimal place. It'd be the same as if having 6 and 2, the decimal starts here, but we move it over 2 places, so we have to add another 0. If we count from this position right here, 1, 2, we now moved it over 2 places just as it's telling us there. To multiply by a power of 10, simply move the decimal point the number of places shown by the exponent. In this case, we move the decimal point 2 places to the right. Sometimes powers of 10 are named with words instead of numbers. For example, we might read that the population of Hong Kong is about 6 8/10 million people. The number 6 8/10 million means 6.8 times 1 million. We can write this number by shifting the decimal point of 6 8/10 6 places to the right, which gives us 6,800,000. So in this case, the answer was, if this example, 6 2/10 times 10 squared is the same as multiplying it by 100, which moves the decimal place 2 places to the right. Example 4, write half billion in standard notation. Well, half is the same as 0.5, and billion means we need to move that decimal place over to the right to match up with a billion. So there's a million, we need to have that many zeros. So we're moving it over 1, 2, 3, 4, 5, 6, 7, 8, 9 places to the right. So if I start with my 5, and I'm going to put the pencil right next to where the decimal is in 5/10 or half, and I move it over 9 times. So this is once, twice, 3 times, 4, 5, 6, 7, 8, 9. The decimal would be in this position. For every valley, I need a 0 filling the gap. So this would be my answer in standard notation, placing commas every 3. So I'd have a comma here, I'd have a comma here, and it looks like it would be 500 million. So in this case, using powers of 10, you could write that as 5 times 10, and you count how many zeros there are. 1, 2, 3, 4, 5, 6, 7, 8. That'd be 5 times 10 to the 8th. So a half a billion is the same as 500 million, or 5 times 10 to the 8th power. All right, so let's find the sum or difference here. So if you have 6 feet 5 inches plus 4 feet 8 inches, your sum will be, in this case, you have 10 feet, because I know what 6 plus 4 is, and I know this is 13 inches. It'd be 10 feet 13 inches, but this 13 inches is the equivalent to 1 foot, and it looks like 1 extra inch left over, because I remember that 12 inches equals 1 foot. So because 12 inches equals 1 foot, 13 inches is the same as 1 entire foot with 1 left over. So that means I'm going to have 11 feet 1 inch for my final answer. That's the best way to represent that. It would not be 10 feet 13 inches, but 11 feet 1 inch. All right, here's another mixed measure. 3 hours 15 minutes minus 1 hour 40 minutes. So in this case, I cannot subtract 40 from 15, so I need to borrow. I'm going to borrow 1 hour from this, which will change this to 2 hours. And if I'm borrowing 1 hour, I know that 60 minutes is the equivalent to 1 hour. So because of that, I have 60 plus 15 here, which makes 75 minutes. So 75 minutes minus 40 minutes, I know off the top of my head is 35 minutes. And 1 hour minus, taken away from the 2 hours there, leaves me with 1 hour. So the answer would be 1 hour and 35 minutes for letter B. All right, for letter C, D, E, and F, write the standard notation for each of the following numbers. So standard notation, if you remember from the lesson there, it said just move the decimal place, the number of exponents, or the number in the exponent there. So it's 4 places. We're moving it to the right because we're multiplying it. So I'm going to put 1 and 2, and I'm going to start my pencil in this position right here. I'm going to move the decimal to the right 4 places because it says then that's the number of exponents. So if I move it once, I'm going to move it twice, so I have to fill in that gap. There's 3 times, so here's 1, 2, 3. I need to go one more time because it says 4 there. So if I'm moving it that far, this answer would be 12,000. If the decimal is between the 1 and the 2, there's moving it once, there's moving it twice, there's moving it 3 times, there's moving it 4 times to the right. The answer of 1 and 2/10 times 4 to the 4 or 10 to the 4th power would be 12,000. Letter D. So we're going to write the standard notation. We just want that in millions. So this would be, if you know what a million is, that's the same as this. So you see that it has 1, 2, 3, 4, 5, 6 zeros in it. So that means I need to move this decimal 6 places to the right. So this in standard notation would be 1 and 5, and I'm going to move the decimal once. This would be twice, 3 times, 4, 5, 6 times. So 1, I'm going to double check that. If I have my pencil marked right between the 1 and the 5, and I'm going to move it 1, 2, 3, 4, 5, 6 places to the right. Here's 1, 2, 3, 4, 5, 6 places to the right. So the commas to separate that would be right there. This would be 1 and 1,500,000, which is the same as 1.5 million or 1.5 million. Billion. All right, let me just add this right here so we know how many zeros a billion has. So it has 9 zeros. So that means I need to change this to, I'm going to put, instead of a half, you should know that this would be the same as 2.5, which would look like that. So I'm going to take out that decimal real quick because I'm going to replace it with, once I move it 9 places, so I need to move it over 9 places, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to stop there. Why? Because I know that if I'm going to count 9 places and my decimal starts right here, I'll probably end up right there at that end point right there. And if I ended up adding another 0 in there, no big deal. But here's what it looks like. If I'm starting between 2 and, so 2.5 would have been 2.5, I'm going to count 9 places to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9 places would be right here. So technically, I don't really need those last 2 pieces, and then I can go back and put in those commas in positions that I need. This would be 2.5 billion, which is 2,500,000,000. Letter F, 250,000. So 1/4 of a million or 1/4 million. It's another way of putting it. You could also think of it like this. This is 1/4 or 250,000. So we kind of need that information. You do need to change your mixed numbers or fractions into decimal numbers before you multiply them. And again, a million was simply using, this was a billion before, I'm going to take off those 3. So that means I need to move the decimal 6 places to the right of this. So I'm going to go 6 places to the right, that would be the same as multiplying it by 1 million. And there's 1 million. And if I multiply it by 1 million, I've got the 2 and the 5 will still be there. I'm going to put the pencil mark right before the 2, and I'm going to move it over 6 places to the right. Here's 1, 2, 3, 4, 5, 6. I'm going to double check that. 1, 2, 3, 4, 5, 6. Yes. And I need to put the comma in the place. This would be 250,000, which is the same as 250,000 in standard notation. All right, excellent work today, guys. Make sure you do written practice 1 through 30 on lesson 113, and we will see you tomorrow. Have a great night.